So you're all gonna breathe deeply for a moment and think nice thoughts about this demo and talk, because they've changed the security software on our laptops recently, and I've not had any issues until I came down today, and I cannot get it to join the Wi-Fi in the room. So we're in the basement, and I am tethered to my cell phone, and it is toggling between 1 and 2 signals. And this is a talk about using cloud services. The presentation is on Google Drive. So pretty much we are attempting every bit of fate that we can tempt here today. So think positive thoughts. We'll ping Google right before we start, make sure we're still, all right. So because I'm going to be clicking in and out, I'm not going to even go into presenter mode here. I'm just going to talk through it. So basically the reason we even wanted to talk about this, like this group runs a diverse group. So we have oftentimes statisticians or sometimes medical practitioners, academics, and then we have folks who come from a much more software development background and know the way around operations of a computer in terms of installing software, configuring servers, those type of things. And so sometimes what seems obvious to one person is not to another. And when working on data science, a lot of times you come into a variety of reasons that it's advantageous to use a remote machine. And you see folks that are not necessarily doing that. And so this is kind of meant to be a quick survey of a whole bunch of stuff about remote machines, not as much an individual how-to for any one of these technologies. But you know, we can talk about, for anybody who wants to dig into a specific one, how you would go learn more about that. So we'll talk about what reasons you would want to do this, talk about what that can mean in terms of just having like a shared workstation or server that might be in your data center or might be at your house that you're going to use for things. Then we'll talk about cloud options around that, and then kind of wrap up in questions. So first, why we might do this. Especially in the machine learning area and the AI area, if you're going to get into wanting to use high-end hardware. So the example I give here is a GPU that's a video card, dedicated video card. So anybody into gaming, you know, you might buy a high-end video card for a PC if you're going to play video games. There's also the TPU I've listed there. Google has a product, tensor processing unit, that they use in their data centers for the same type of purpose. So those are not for video or anything, they're just simply dedicated for machine learning. We've talked about this in other deep learning ones, I won't go into that, but basically it does large parallel linear algebra, which is exactly what machine learning does. So you can do deep neural networks and things with millions of parameters a lot faster than you're going to do on a CPU. A lot of other traditional machine learning would be, you know, done on a CPU. So even then, though, large data sets might be larger than a practical laptop hard drive, or large data sets in memory, right? You might want a machine workstation with, you know, 32 or 64 gigs of RAM, which is again outside of your local laptop. So locality of data, right? So maybe you want to work on a data set that's already up in the cloud or already in your data center, and you don't want to, you're going to be regularly accessing that data, batching out to it. It's just more practical to have a machine that has proximity to the data as opposed to, again, a laptop out where you may be working. And then lastly, long-running jobs, right? So, you know, if you see someone not doing this and they're like walking around with their laptop open because they're afraid about a model build stopping, you know, this is how you know they're doing it wrong, right? You don't want to be, you know, especially, you know, laptops are often on Wi-Fi and things like that, so you can have connectivity issues, imagine that. So, you know, the last thing you want is that to kill, you know, particularly in deep learning, you can have models that run for days and days and days. You don't want it to die out because of a network connectivity or a machine goes to sleep. All that makes sense? All right, so some of the pros and cons of kind of a dedicated workstation, a machine you're going to handle. So obviously you've got upfront costs, but the minimal recurring costs, right? The power to the machine is all you're going to pay on an ongoing basis once you own the machine. And that can be a dual purpose machine, right? So Sometimes, if you have a small office and you're have a dedicated server there doing other jobs, it may be able to be borrowed and repurposed for some of this. Similarly, even the machine I'll connect to, so I have a desktop at home that I dual boot. Some things on Windows I'll do, PC gaming, that kind of stuff, but I'll reboot the box and use Linux with a GPU to do deep learning stuff. So removing, I said remove. That's supposed to be remote power up can be an option. It can be a challenge, right? So this is a machine it's a physical machine that you manage the whole machine somewhere. So in the case of, like I said, a dual booted machine, or you have a power outage at your office, you may have to physically go into the office to power up that machine. And you're responsible for everything, right? You've had to buy or configure the hardware. You've had to install the operating system. I mean, literally, you are top to bottom responsible for that machine. Is on the con side. So to talk through some interfaces that you would use to that machine. So we could use a terminal. In this case, we'll talk about a terminal multiplexer. We'll get into what that is and why in a second. Jupyter is a Python package, but supports a number of data science languages. Is a web-based interface. We'll talk about notebooks and labs, and we'll quickly touch on RStudio Server as well. So Tmux is my preferred way to do a remote terminal. So it's a program within a terminal that's a multiplexer, meaning so that while you have one terminal, you can act like you have 3, 4, 5. It's kind of windows of a terminal or tabs of a terminal. You'll notice my note here. For older folks in the room, think about screen, right, as the equivalent that used to run for this.
And it still works.
It does. Are you saying you're an experienced developer, Brian?
I'm not an experienced developer, but I'm old, so I think it's just age.
So I'll pull this up. Thankfully, too, I actually did, because demos can be terrible. I screen capped all of this so that if I have to, I can pull up the video instead. But we'll try to do this the old-fashioned way. Yeah, let me bump the font. One sec here. All right, I think I can just, yeah. Of course, now I've made it big too. Is that okay?
Yeah.
All right. So we'll come back to this. So I've got a host entry for my desktop.
At home?
Yeah.
With the static? I'm sorry,
My IP is on a cable modem. It just doesn't change very often.
Okay.
And I actually have a cron job that will log the IP out to Dynamo. I will show in a second, though, something about my SSH config that helps with this. So this is my box at home. So you can say, I'll see if there's any sessions going. So there's not. So just run tmux. That starts it. So now you see this green bar at the bottom. That's your indicator you're within tmux. So I can rename this window. So let's say I'm going to spin up a Jupyter server. All the commands here, so you have a prefix command, Control A by default. I've remapped it to Control \, but to not conflict with shell and Emacs stuff. So when you're going to do something to tmux, you type this prefix first. So it's a prefix you configure that's not something you're commonly going to type. So like the prefix and then comma says, okay, go ahead and rename the window, and then I can type in whatever I want, hit enter. Now I'm back. Anything I type after that is back at the terminal. So I've renamed that window. Before I run anything else in it, I'll create another one. So prefix C is going to tell me to create another window. So you'll see now I've got one ZSH. That's like another tab being opened up. And if I type something here and then I use prefix next, I go back to my first window. You see it's gone. Do next again. Come back to it, you see that text is there. So, more importantly, I'm going to do real quick, I'll come back in and do some useful things in here, because you might be asking why. By the prefix D, that disconnected me. now I'm going to run tmux attach. I'm right back where I started. So I could have actually even disconnected from the machine and then gone back in. So now whatever I do within that tmux session, my SSH config, which is the remote shell connection, can get killed. It doesn't matter. Those jobs are not going to stop on that machine. They're going to stay within that tmux session, and I can go connect from another machine. I could actually sit down at my desktop at home, type tmux attach, and be looking at the same session. And actually, it's weird because then remotely I would see the characters getting typed in that session. It's almost like remote desktop type of thing, like multiple users for a session. So with that in place, let's do some, actually, yeah, we'll talk about Jupyter next. So I'm going to that Jupyter tab. I've got a virtual environment installed in Python. That's like a library group. But you can install it in the system one. The command's just Jupyter, and then I'll say notebook first. We'll demo them both. Brian, gloss over a few magic things here. We'll come back to that.
But you've tunneled this forward.
Yeah. Yeah.
Your tone is doing remarkably well.
It is. Think kind thoughts about AT&T right now. So this is Jupyter. So it's code within these cells. The state from the last time it was run is there. So this is Python code that is loading up a data set and doing some data augmentation to it. So it's taking a picture of a cat and shifting it is really so this is a technique called data augmentation in machine learning. We'll get into what the code actually does, but Jupyter's we've had talks about this here before. It's a format for mixing code and markup, so you can kind of write documentation type things. It's pretty good for exploratory analysis and whatnot. So now, though, anything I run within there, since this machine's set up, its Python environment is tied to the GPU to be able to do deep learning with libraries like TensorFlow and Keras, I'm running any code that runs in this web browser is running on that machine. So it would be GPU enhanced and running there. So as a matter of fact, to just prove any of that, anything I run with an exclamation mark in there is going to be run as a shell command. Let's see if I can do this. Yeah. So by running uname A, you see that in fact it's Linux. It's not but obviously I'm locally here on a Mac. I could disconnect that Jupyter server would stay up and whatnot. Kill the Jupyter server for a second. So Jupyter launched with notebooks first, but more recently came out with Jupyter Lab, and I think this is worth changing over to. Let me actually do one. So Jupyter Lab is closer to like an IDE in the web browser. It still supports, so I can open that same Jupyter notebook, but I can do full code edit, and I can launch terminals. And once again, I know that's small. It's all running remotely on the machine. So if you go to a coffee shop and you're going to work on a Kaggle type problem, like this is common for the data science user group around here, right? But you want to have work on a GPU to be able to train faster. You can work this is your IDE on a remote machine, but just take a Chromebook with you or something like that. Question? Oh, you're saying like a REPL?
Yeah, if you want to walk through your Python script line by line, command enter, how our can send it, or...
So a Jupyter Notebook would allow you, of course, to do that. The other option, though, is in here, you have a console, and there you pick your, so yeah, now I can do, I've got like an IPython. This is a REPL right there.
And you can't stand it from your script. You could like highlight 5 lines.
Oh, I see what you're saying. No, you would generally, for chunk by chunk, you would want to do something in Jupyter, likely. Here, I think I get command history. Whoops. So if it's the shift enter. And then if I do, yeah. So I could do, I mean, yeah, you could do it in this console with command history, but it's not as elegant as what you're talking about. Yeah, I don't think there's like an interactive debugger type of option as well. So let's click over here. We were talking about, so we talked about Notebook, we talked about Lab. RStudio Server, so I think it's worth pulling up here. So RStudio Server has a pro, but also an open source version. So there is a freely available version. This is RStudio in the browser. Because of the integration with some of the deep learning libraries, like so the packages that they build around TensorFlow and Keras, to bring that over into the R world, you can take advantage of a GPU for deep learning from R. So that same advantage could be there, or there could be other reasons that you prefer to be again on a remote workstation. This machine I'm connecting to has 32 gigs of RAM. Obviously, you can build workstations with much larger than that, which would be advantageous for extremely large data sets and things like that. And again, locality of data, other reasons. It's a pretty straightforward install. Let me just pull up the page because I like that it yeah, so like on this is running CentOS at home, so it's like 2 commands, right? For anybody comfortable on the Linux side, you'd be doing a wget, which is, you can of course download through a browser if you wanted to, the install file, and then you're just installing it through manage the local package manager for any dependencies. Then it's running as a service, and I bring that up. So now you can see your regular RStudio running in a browser, and obviously all the RStudio shortcuts work, so I'm control entering there to execute line by line and those type of things, right? So
I'll just mention something interesting about the server. So this has been corrected, I think, in a very recent version of RStudio, but for a long time, for years, the RStudio server version, because it runs in a browser, often had better support for WebGL. The packages like FreeJS and other WebGL-enabled, OpenGL-enabled packages often ran much better in RStudio server than in RStudio desktop. For a long time. I think more recently they've updated that desktop version. But sometimes the server can actually be better. I run it locally usually for that reason. Because Chrome always has the best GL support, right? So,
yeah. So it's funny you mentioned that, because I actually had an error back to my company's security software that I'm very happy with. Talking to the camera there. That's the public line. No, so right after it installed, I didn't realize I'd had like a browser up with my R profile file and editor, and I had fat fingered something and saved by accident and didn't realize it. And so I opened up RStudio, and it was giving me an error, and I should have read further into the error, but the part I noticed right away was like, can't connect to localhost, blah, blah, blah. And I was like, why is this even, it's like doing a local connection just to run RStudio. And so I thought like, oh, this is new firewall software or whatever else. submitted a ticket, then read the error message further and had to unsubmit my ticket, go delete it, because in fact I just had a config problem. But it seems to be, like, I wonder if they haven't merged those product lines where effectively you're just running, when you're running RStudio, you may just be running a browser with RStudio server locally.
Oh, no, I don't think so. I think they're using, it's a pretty different code base. They've got an embedded I can't remember what he's using, but there's an embedded, all the web services within the desktop version are part of the desktop version, and they're independent of, like, they're not using V8. They're not using
All I know is it was giving a can't get to localhost because it crashed before it would even go to the page.
So it may be because of another web framework that they're embedding in theirs, but it's definitely not like
Gotcha.
Chrome.
Brian probably made the comment before that was tunneling. So Jupyter is by default bound to localhost. RStudio by default is bound to localhost, right? So even though I'm SSH to those machines, and sorry, you're all like, we just want to do data science, we got to talk ops things, but we got to talk ops things. So the issue is those things are meant to, until you configure them to be available on other ports, just be secure by being bound locally. I did not want to go expose those things to the web and find out what kind of vulnerabilities there are or not in Jupyter and RStudio and all those things by port forwarding so that anybody outside my cable modem can connect to them and do that. So instead what I've done is SSH tunneling. So that's the kind of thing. So this is an example of what an SSH config entry would look like that would forward those things. So if I thought I had on the slide, I don't. So this on a Mac, this would be in a config file that goes in your .ssh directory in your home directory. So it's a hidden directory, and that host desktop so now desktop is an alias for this connection. You see, I give the actual host name, which is an IP address. Forward x11 you can ignore for now, but the two ports I wanted to forward are something called TensorBoard, that actually I didn't show, I'll show that in a moment, and in Jupyter. And those forward lines say, take those local ports and bind them to this remote address. So on the remote server, it takes any connection locally to 8888, goes to the remote server, and then says, this should be the actual output, localhost 8888. So any of that traffic that happens, it actually comes back through the SSH connection. SSH is encrypted, so now everything you do is encrypted. So you don't have to, you can, like RStudio has authentication built in already. You would want to leave that in place because that's kind of tells it which user on the machine you are. But Jupyter can take a password. These other ones can take a password and be encrypted, or you can add a SSL certificate and all that stuff. If you know how to SSH tunnel, it's way, way simpler. And then by having that entry in there, you saw I didn't have to remember, like if you just Google SSH tunneling, you'll see the long commands of how to do it at the command line. It's terrible. Set up a config entry like this, and then you do it once and forget about it. I didn't show TensorBoard, so I will real quick. This is kind of specific to deep learning, but again, I would just set up if you're working in TensorFlow or Keras, then TensorBoard's a web interface that shows you like progress and some of your variables and things that are involved. So that directory I picked, that's where in code. I'll show an example here. So this is Python deep learning code. I've configured TensorBoard to go to a directory that's a constant, so it doesn't really help a lot. But I'll just show the interface. Because again, these deep learning jobs can be wrong port there. Yeah, 6006. So this is a way even like multiple team members can check in on long running jobs. You can here I'm looking at the accuracy metric over time, those kind of things. So again, the point isn't to intensive order. The point is that this is a remote interface to your job, and I've got all of these connections coming through one SSH connection. I just did it with a host entry. You mentioned, my IP not changing very much. I just want to touch on here. We won't talk about or demo it, but there are services out there called dynamic DNS services. So you register for some kind of a name. I've listed some providers here. This dyn.com, noip.com. So you would end up with a host name, something like, for me, hoolihan.dyn.com. And then I'd have a small script running on one of my local machines. It will connect up and regularly feed its IP to that service, and that service keeps the DNS record updated. So it's like having an address instead of lat long, right? It's just friendlier to send mail to. That's the best way to think of that. So all of this, right? Like I see some eyes glazing over, some people wanting to do data science and not think about all these things. They're hard, right? We don't want to manage this workstation. We want somebody else to do it for us. So maybe we should look at the cloud. The cloud services for data science are all the rage and changing a lot these days. So we'll talk through what that means, various instances. Cloud started off with kind of infrastructure as a service, so just a remote virtual machine running in the cloud, and we've gone up and up and up and up the stack. And so we'll kind of walk through those. So a cloud instance. Cloud instance is infrastructure as a service. Like I said, a virtual machine hosted in the cloud. So the examples of this on AWS, Amazon's, that's going to be an EC2 instance. So you just pick up a machine size, tell it to spin up, and go. Google calls it Compute Engine on their cloud. And Azure calls it Azure Virtual Machines on their cloud. So easy remote startup and shutdown. So compared to our machine, my desktop sitting at home, I don't have to worry about power outages and things. I can always kick off a remote machine in the cloud and start up another. No upfront hardware costs. You don't have to buy anything for that. You just pay by the hour for the machine you're using. There's a bunch of pre-built images available, so when you boot it up, you can have pre-installed on it. Your operating system of choice, some associated packages with choice, those type of things. So you're still responsible for OS administration, networking config, and I don't mean like out of the box there's a default networking if you're just going to connect to that machine. But if you're a company that's cloud embedded, like our company does most of our development in the cloud, then you have what they call VPCs, which are kind of like your private networks within that. You have a lot of permission structures, those type of things. That's when it gets hard and complicated to set up. Permissions in the cloud is like its own thing, and there's these long, very long files of JSON that are terrible to deal with. So let's take a quick look at what that looks like. So actually, because of the connectivity issues, I'm going to steal my pre-baked here. And of course, I don't have a good one for it. All right, we will look at that. So this is AWS's EC2 service. We're going to launch an instance. I won't go through it. It takes some time to actually get started, but just to show you, so I've got a number of OSs here available out of the box that I can pick. If, let's say that we were going to run RStudio Server, if we just search on that, RStudio Server, you see 7 results in the marketplace, 13 in the community AMIs. So if we click on that, community ones are going to be the free ones. So folks have pre-made images that already have RStudio set up in a default config. Or you can go to the marketplace and do that. Marketplace just means you're going to pay an additional price per hour that goes to the software vendor that set that up. You'll notice the very first one, though, is set up there by RStudio themselves, and that's actually free. So it's per hour. So if I selected that, you'd see, okay, here are the instance types that are compatible with this. And then I would actually go pick the instance. And here's where the fun begins. This is all the networking, your permission config, and all those type of things that I was talking about. If you're just going to connect to a virtual machine, most of the defaults here are sensible, and I could just hit start and go if I was going to work in isolation. Terraform comes in friendly here. This is for what we're doing here. Like if you were going to do a single data science instance for yourself, Terraform is completely overkill, right? But if you're going to do this for a team and you're regularly going to be standing up a lot of boxes, Terraform is a nice way to script and save these things. So I'll show you what a config file for this looks like. So bump that up a little bit more. So actually Terraform is like cross-cloud compatible. So you'll see here that I have to say that I'm in AWS, tell it where our credentials are. There's a number of environment variables you can set so that this can be run by different people or those type of things. Details about the instance, details about the IP, and things. Again, Terraform is its own talk. I mean, it's a huge topic. But then the result of that that's pretty impressive is so I recorded this one especially because I want to edit for time. See the config file here. Go into a terminal. Do a Terraform init that just checks your config, kind of compiles your plan along with the plan command. Plan will show you this is what all we're going to build, and then I say apply, and now it just takes that plan and goes and builds it. Because it prompts me once to say yes. But for time there, that all the output took like 3 or 4 minutes to create, but now you see an additional machine in AWS with all the config stuff I wanted. Particularly cool then, I go back to the command line here at the end of it and say Terraform destroy, and it actually tears down every single thing it put up. So all the permissions, the IPs, everything that it created for it is wiped from your account and shut down. So it knows how to clean up after itself. There's a number of different tools in this space. Kind of even a step over Terraform, sort of generally aimed at the really large, like number of I'm going to stand up clusters of these machines and do that. You can go on down to like Ansible, Chef, those type of things for more individual setups. But it's nice, the motto in that space, a lot of DevOps is cattle, not pets, meaning that so the metaphor comes from the pets you love. You've treated them differently and done little things to them. But now if that server crashes in the cloud, you loved it and there's pain and you don't know how to recreate it and all that. Versus cattle. Cattle you don't name. They come, they go, and and everything's configured the same.
Can you connect easily connect what you just brought up? The only thing in the nasty public DNS thing, so you just say Terraform connect.
That's a good question. I've not done that because generally, I even, to be honest, after building it in Terraform, sort of thought I should have done this in like Ansible. Because I think Ansible does do that for you. And Chef had the connect to that level. I don't know. That's a good question. So cloud notebooks. So this is when we start to step up the stack into platform as a service. So I don't want to think about some of those permissions and all these other problems. I just want a machine configured for me. So I still want to use a GPU machine, but I want notebook access to it, and I don't want to think about it. So SageMaker Notebooks on AWS is what this service is. It's Data Lab on Google, and it's Jupyter Notebooks on Azure. So easy remote startup shutdown again, no upfront hardware costs, pre-built images, so I can still pick some of those pre-built images to actually run the machines under the hood. It's got to be one that's supports the notebook, but there's still a lot of options. And most of the networking permissions are set up for you. So by default, you can say, run it within this part of the network. It's going to have permissions to the same things you already have permissions to. So cloud storage, things like that. So in Amazon, that would be like S3, right? So it's common to have like large file storage out on S3. It's these virtual drives, and your image is going to have access to that. You do have a note here on a con, less access to the machine. There's things you can tune on an EC2 instance that you just can't in a notebook service or can't access. So here I've got one. We'll go in and show both kind of what it would look like to configure one, but then I'll spin up one that's already running just for time. So go in here to notebook instances. And I'll start one. Yeah. So while that's doing that, I'm going to I'll back out of this. We'll just make up a name. I can pick an instance size. Can't actually tell the user they've got root access, so they've got Jupyter terminal. I guess you could take back what I said about you could get pretty low with the machine. Git repository, so by default you can have it check out Git repository as a part of the setup. So the nice thing then is this configuration, you can all spin up future notebook instances and say do it just like this other one, so it'll already remember what Git repository to get, and you hit create and we'll go get it. It takes some time, so rather than that, I'm going to connect to one here. Looks like it's still pending. Give it a moment. If it doesn't kick off soon, I'll Alright, so I'll show the video version since that's going a little slow. Notice though on the right here you see that Open Jupyter or Open to Jupyter Lab. So it has both by default. I'll skip forward on this because we did the config part. Yeah, here we go. So there I clicked Open Jupyter. And now I can create a notebook. I picked notebook there as opposed to lab, but again, that lab I think gives you a few more options. This is our notebook. You can name it and then show the, just like in a Jupyter notebook. And you're only charged while the machine's running, so once you go into notebook instances and then stop it, it's just saved, but it's not incurring charges. So that's another good option when you're looking to work on something like a casual competition that requires a GPU or something like that. So we demoed that. Cloud service. So SageMaker, you might have noticed when I was in there, there's a whole bunch of other options around that. It said like training jobs, inference jobs, whatnot. I think that's its own talk. I think we're going to try to find somebody actually who does one of these services to come and talk about it. But SageMaker on Amazon, or ML Engine on Google, or machine learning services on Azure, what they allow you to do is you kind of code to an interface, and then the training jobs for machine learning can be, it's like put into a container and put out on cloud machines and run for you. And then all the results are stored automatically in cloud storage. It just does a lot of the provisioning and the headache work for you. It has its own way of parallelizing jobs that's different than what like TensorFlow does to parallelize jobs. It's up and down. Like those services are early, so like the learning curve is really steep. I think I note that in the cons here, because everything you're coding, you're kind of coding to their interface. But if you get comfortable with that as a cloud-first development, it's very, very flexible. You can run really large ML jobs and not pay a lot of cost until you get specific to the running. Do you want to make a quick note here? I'll blast back through the slides. How much better is Microsoft at naming things than everyone else? So look at these. Their virtual machines are Azure Virtual Machines. Their notebooks are Jupyter Notebooks on Azure. Machine learning services on Azure. It's like you actually know what Amazon, you need a dictionary all the time to remember what these services do.
Isn't there a thing called Sage Notebooks?
There is.
Sage that? So
Yeah,
I'm
the
thinking
stick-
now it's going to be Sage. Not a Sage notebook, not a SageMaker?
I think you would just, you could spin up you would spin up a EC2 instance with that. I mean, I'm sure there's images for that, but I don't think.
I'm just saying, you're calling it SageMaker, like how they own it.
Yeah. Oh no, it's terrible name. Terrible name.
It's not even a cryptic name, it's like a SageMaker.
Yeah, and because both of those notebooks, they save as IPython notebooks, like the Data Lab and those, but when you spin up their notebook instances, they are like opinionated interpretations of, like the actual interface you're getting is Google's custom spin on Jupyter, essentially. So lastly, and I heard somebody talking about this with Kaggle.com, I wanted to point out, if you're working on those problems, one great option, if you were to go to like Takuya's group, you go over to the Phoenix Coffee House on a Saturday morning and you're going to work on a Kaggle. If you go to one of these competitions, say kernels, new kernel, you can do as a script or a notebook. We'll pick a notebook here. But Kaggle will actually provide its own notebooks in the cloud that are yet another interpretation of Jupyter Notebooks. And within the settings, I can pick Python or R. I can request a GPU instance. They try to obviously, you're limited by users as to how much of those you can use. But, give it a second here. So this is specific to this problem. So if I control enter and run this, because you'll see the code here that's saying list the files in the input directory. Those are down at the very bottom here. That's the same files you get when you download the competition files. So now this instance can be run and saved and worked on that. I overheard the comment of for folks who can do a machine learning kind of profile or portfolio type thing, right? I could give this a sensible name, make it a public kernel, and say, yep, this was my attempt, to explore the data and build a model for the housing prices project. So a number of folks trying to break into the field and learning things, that's where they work. So just kind of wrapping up, we talked about why even do this at all. We looked at workstations and all the issues and things you have to set up in terms of interfaces, all the different ways in the cloud you can go up to that. And that is about it. I list some resources here. I'll put slides up, and then of course the video will be up as well. And really here, this is just, I've got a couple of the Terraform scripts up there. I'll actually, before I post these, I'll update the URL to be the full path through the Terraform script. But then the kind of getting started for each of the cloud documentation, if you're interested in looking at those. For Kaggle, just head right there, and there's a number of links that kind of talk to folks of getting started. Questions?
So for when you're trying to retrieve X, you always have to SSH in first, and then you can, you said like, oh, when I go to my other machine, I can do lots of cache. So I have to SSH first.
No, I mean, so if I sat down on the actual machine it's running on, like because that's connected to, in that case I was connected to my desktop at home. If I was at my desktop at home, within a terminal I would just connect. Yeah.
Is SSH, in the old, you're a Windows guy, right? So is SSH on Windows finally in the terminal, or do you have to use PuTTY or something?
So one, thankfully I'm not really much of a Windows guy anymore.
Oh, you're not?
But,
Okay, all right.
but
That's right, you got a Mac,
I can still,
yeah.
but yeah, so most folks on Windows, you either go one of a couple routes. If you just need to SSH and you're not doing a lot else, there's a client Pageant, and PuTTY, Pageant's the key manager. But yeah, the whole PuTTY suite would allow you to set that up. But there's also the Unix.
They're changing the terminal in Windows, and they're just going to put all this. I mean, there's a Windows subsystem for Linux, right? And I think
So like you
SSH
got.
SSH is going to be part of the thing. I don't know.
Yeah, I don't know how far it's gone. So yeah, and I just want to roll back a step and say, obviously, like Cygwin, stuff like that, they would install the Linux tools on top of that. But I think you're right. I don't think it's as necessary as it was. Because so there used to be limitations on Docker on Windows. I think that's all real because I think they've just been adding the
Windows 10
POSIX
uses the Linux
guts
terminal,
to the.
for example, right?
Yeah. Yeah. So I think that's getting easier. But for these purposes, I mean, PuTTY and you would be done with everything we did here, and you'd be fine. Yep.
Do you have resources on some of the basics with setting up your own? This is all resources for cloud, supporting your own workstation. Is there I know it's a big topic, but where do you start?
Yeah. That's a good question. I mean, honestly, in that, it would be, it kind of depends, right, on where you're starting. Like, that machine I connected to is a machine I actually, ordered parts and built, because I wanted some very specific stuff. But, I mean, if you just even went to Best Buy and bought a machine off the shelf and installed Linux, and you would obviously then be looking for, guides to install, probably the most common home flavor would be the Ubuntu. You would look for guides to install that. You would look for, you'd have to port forward to SSH, go through your router.
More of a networking project.
Yeah, and then, I mean, really, most of what I was doing here is all tricks around SSH tunneling. I will add some links on this before I post it about how SSH tunneling works. Because the nice thing about the SSH tunneling is when I mentioned the port forwarding, you're down to just one port you forward. And that's going to be specific to your router, but most routers, somewhere in the advanced config, will let you forward a port. So you'll say, any public traffic that comes to port 22, bring it internally to this machine at port 22. And you can also, the nice thing, SSH is secure, but I mean, you could make the outside port something different. A lot of people will make it a nonsense port, so that it isn't as obvious what you've exposed to the world. But I will, that's a good note, I'll post some resources.
Yeah, another tip that I would just add is that, SSH is secure, but it's had some infamous security holes, OpenSSH in particular, in the last year, that have been corrected quickly. But for logging into a machine behind your own home router, I would only allow password-less SSH, not even a password requiring a RSA of large, like a 2048
Yep.
RSA key. And it's easy to set up, right? You have this public-private key, you put it on the server, and then once you do that, and then in the server config, the SSH config file, you can say disallow passwords. I forget the name of the option.
Yeah.
It's an option. And that way, because it's amazing, if you put like Wireshark on the network, and you open an SSH port at home, you'll immediately start seeing like dozens per minute of attempts to log into that machine with common passwords. So the network, the internet finds you, and it's like malicious. I mean, it's shocking to see. Like once you open any port, pretty much, it's like immediately under attack, anywhere, right? Which is insane, right? But so you have to guard against that. In a good way is to just not allow passwords, and then those passwords. And you can also, another thing that's worked people is to put like the retry time to be a long time, like 5 seconds, and that really hurts these bots. You just can't like DOS your own network with attempts to log in.
So yeah, I brought up the line here. I use a SSH key, and you see the password authentication no down there.
There you go.
And that
Yeah.
forces you to use a key.
Yeah, you definitely want that, I would say.
Yeah.
Way more secure than the password.
Is your file running?
SSH config. SSH underscore config.
Yeah, which is SSHD underscore config in Etsy.
You can, it's in SSH, you disable block with your password after you.
Yeah.
Yeah.
Forces you to use a key. An encryption key.
And you could put a password on the key if you wanted. In addition, I mean, that's
Yeah.
you're asked when you create the key whether you have one or not. For anybody who does GitHub authentication, right, you probably have a public key from that already set up.
Yeah, I'd highly recommend that.
Other questions?
There was some nice from our technical, like, people are allowed to set up their own home web server. Which gets to the data science part, so I can put it on the web.com.
Okay.
Just to get you the dollars with the server, and it does the trick about not exposing 422 for that same chain with no random number.
Yeah. Yeah, I mean, the home setups are, I would say it's worth considering, right, like how much time you're going to put into it. And if you don't feel very comfortable configuring Linux and networking and stuff, then I would definitely look towards the cloud ones. Like for someone to try, because then, especially if you're, the example I keep using of going to one of the other meetups around Kaggle and you've got a couple hours to work. The last thing you want to do is get there, you can't connect to the machine where you thought you had everything set up and ready to go, and then you're stuck. I mean, a cloud instance is going to be a lot safer for that. But
my use case is I just work with that option, and I have no idea what they're paying, and I already know how to like begin to understand. So that's why I'm just trying to understand the paying, because we do all that stuff in Linux space, and like just using it from that.
gotcha. Yeah, I mean, if it's to learn how to do that for its own sake, then this stuff's a great way to play around with it.